Hello everyone, so let's continue our conversation on acids and bases, and in this video I want to look at some technical details regarding the pKa or the pKa and pKb concepts. So to do that, we're asked the question of which is the stronger of the following two acids. So we're given acetic acid and we're given its Ka value, and we're given chloroacetic acid and we're given its Ka value. All right. And so hence, the only way that we can compare these two acids with each other is if we're comparing apples with apples. So meaning we either need to compare both of their Ka values or both of their pKa values. And so hence the question is, how do we convert a Ka value to a pKa value or a pKa value to a Ka value? So let's do both. I mean, it's a good exercise. So to get the pKa of an acid, you say pKa is equal to negative the log of the Ka. It's like the pH. Remember, the pKa is our logarithmic scale for the Ka, just like the pH and the pOH is a logarithmic scale for the hydronium and the hydroxide ion concentrations. Right, because Kas and Kbs vary and are very small numbers, we developed a logarithmic scale called the pKa and the pKb to give us the same thing. And if we take negative the log of 1.8 times 10 to the negative 5, you will get a value of 4.74 for the pKa of acetic acid. All right, so now if you have a pKa value and you want a Ka value, how do you solve for the Ka? Well, that means Ka from this top equation here must be equal to negative 10 to the power negative the pKa. Right, just as you would do for the pH or the concentration of hydronium or whatnot. Right, so for the chloroacetic acid, this would be 10 to the negative 2.85, and we can round that to 1.4 times 10 to the negative 3. All right, and then the question is, what is the stronger acid? So now let's remind ourselves, what is the stronger acid? So stronger acids has either, so it's larger Ka implies stronger acid, all right, and hence a lower pKa implies a stronger acid, right? Because the smaller the pKa is, so meaning the closer it gets to 0, then the larger the Ka would be able to be, because you have to take 10 to the power negative the pKa. So the pKa needs to be smaller, closer to 0, because then you get a value closer to 1 for the Ka. And bigger, the smaller the pKa gets. All right, so that is essentially what you want to get to. So therefore, if we compare these things, let's first compare the Kas. So in terms of Ka, let's just highlight them. The Ka for acetic acid is 1.8 times 10 to the negative 5, and for chloroacetic acid it's 1.4 times 10 to the negative 3. So that means chloroacetic acid, so the Ka for, let's call it chloroacetic acid, is larger than the Ka for acetic acid. And the pKa for chloroacetic acid, let's compare that, is 2.85, and for acetic acid it's 4.74. The pKa for chloroacetic acid is lower than the pKa for acetic acid. So from that, and combining it with our rules there, the Ka for chloroacetic acid is larger than the Ka, and its pKa is lower. That means that chloroacetic acid is the stronger acid. Right, and the same goes for the pKb for bases. So larger Kb and lower pKb. So that is how pKa, pKb, pK, all those things work together. Alright, so hopefully this gives you some way to look nicely at pKa, pK, and Ka, and link those things together. And gets comfortable with how they work. Alright, I'll see you in the next example.